Alright, in this overlay example we have some requirements here, and the requirements are to look at the existing ground and look at the cross slope. If the cross slope is less than 2%, then we want to overlay it with a 2% cross slope on our design surface, and we want to overlay with a 3-inch thickness. If the existing cross slope is greater than 2%, then we want to go ahead and match the existing grade and also provide a 3-inch thickness of overlay there. So to do that, the first thing we're going to do in our template is we're going to create two null points up here at the center line and edge of pavement. And these two null points we created by going to add new component null point. And we constrained them to the center line point there. And all they're going to do is they're going to go project a surface and find the existing ground surface. So these two null points, when we look at the slope between the two null points, since they're both going to the existing ground, then we'll know what the slope of the existing ground is. Then based off of that slope of the existing ground, we're either going to put in this cyan 2% pavement, or when the slope exceeds this 2%, we're going to start matching the existing ground. So to show what I've done there, if I just temporarily delete that projected surface and move this point up and down, when the slope is shallower than 2%, it's putting in my 2% cyan line there. But when it gets greater than 2%, it's putting in my orange line, matching the existing grade between the existing center line and existing edge of pavement. So the way I did that is with display rules. I simply created two display rules for these components. I created one display rule that is called existing ground is less than 2%, and it compares the existing center line and existing edge of pavement. And if it's less than 2%, then this rule is true. Then existing less than 2% will display. And I created another one. Existing ground is greater than 2%. If these 2 points are greater than 2%, then this rule solves true, and the one will display. So the one that I wanted to display when it's less than 2% is this cyan line here. And I have existing less than 2%. When that solves true, this displays. And my right edge of pavement point over here, if I go and edit that point, REP, is simply 2% constrained to the center line. So when my display rule solves true, this displays it's always 2%. The right, this RCL point here, is matching the slope from the existing center line to the existing edge of pavement. So to do that, I made it slope constrained from the center line, and then the value, what actual slope value it is determined by using this value equation button here. And it's going to be the slope from existing center line to existing edge of pavement. Alright, so let's put that projected surface constraint back on. And go back to the library there, and we'll see that now we're greater than 2%, so our orange is displaying there. So once the template is constructed in that manner, it's easy then to get our overlay thickness. We'll say OK on that, and we will step through our alignment. As we step through our alignment, we'll see that we kind of have a shallow slope here, or sorry, it's actually exceeding the 2%, so it's put in the orange. If we go to a shallower section, here we're shallower than 2%, and it's put in our cyan component there. So the components and the display rules and the null points are actually doing the testing of the slope of the existing ground. And the last thing we need to do is interrogate the surface at these 2 points to give us that 3-inch overlay that we asked for in the requirement. And to do that, it's pretty easy. We're going to switch over here to an overlay display mode. We're going to go to Overlay Tools, Vertical Adjustment Settings. You can see that I've actually run this once already. My backbone doesn't have any thickness. You notice I just had a simple component that started right there. If I did have an asphalt buildup above that, I'd want to add in that here to move up the vertical alignment to its proper position. My minimum overlay is that 3 inches there that were specified in my requirements. And then I need to interrogate between the center line and the right edge of pavement, and I am choosing to examine only those 2 points in the template to give me that 3-inch overlay. If I set examine all cross-section points, we'll say OK on that, process all, and we can see if we examine all the cross-section points, it's going to look and find the shallowest point in my template, and it's going to make that be the control. It's going to come up and go the slope of the template to define the new vertical alignment. But in this case, I really just want to look at the left and right extents of that, so I'm going to come back to vertical overlay adjustments, and I'm going to tell it just examine the template points only. Say OK, and process all again. And now it's only going to look at my 2 points there. And so as I step through, I can see the little red square in my cross section, and this is a good example here where it has looked at my 2 points. It's found that the center line is the shallowest, so I need that to be the control. It's going to give me 3 inches from there, and it didn't analyze these intermediate points in here, so I don't have that 3-inch minimum in there, but that was specified in the dialog. Once I'm happy with this vertical alignment, I want to start using this for my new template. All I have to do is come in and first of all just run the smoothing, and I'm going to create a new vertical. I'm going to call this one adjusted vertical. Adjusted vertical. Alright, it created adjusted vertical, and then the last thing I'm going to do is I'm just going to apply that adjusted vertical to my corridor there, and say OK. And now my template is using that. If I go back to a normal view, I can see now that I'm going to have my 3 inches either left or right overlay, and then when it gets shallower than 2% on my existing ground, it's going to switch to a component that just does a 2% cross slope. Let's go find one of those stations. There we go. We can see that that is a minimum of 2%.